Hello guys. So in this tutorial we'll be solving the physics problems of coordinated science paper. So the version is going to be October-November 2022. Basically they call it November 2022. All right. So this paper contains 40 questions. So it includes all these three subjects. So first bio, so first 13 questions, okay, in sequence. So first 13 questions is going to be biology questions. Then from 14 to 27 is going to be chemistry problems. And from 28 on till last question 40, it's going to be physics problems. So the instructions are all same. So there are 40 questions, blah, 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 and so on. So let's directly jump to physics problems. So we will be solving, okay. So, if you wish, let me show you the problems, right? So, as a proof. So from first, so the plants, blah, blah, blah. So till question 13 is going to be biology questions, and 14 till 27. Where is it? Okay, so 27 is included. It's going to be a chemistry problems. And from 28 on till last question, which is 40, is going to be physics problems. So yeah, I'll be solving only physics problems. So all right, let's get started. Question number 28. The rock has a mass of 360 grams. A large measuring cylinder contains 500 centimeter cube of water. The rock is now lowered into the water and completely submerged. So it's inside water now completely. The water level is measuring cylinder is going to be, or rises to 650 centimeter cube. So which calculation gives the density of the rock? Okay. So basically, okay, let's get the pen here. So what we have, let's say this is the cylinder, okay. There was a water here, okay, without rock. So the level was 500 centimeter cube, let's say, okay. So then, okay. So then we have another cylinder here, okay. We put the rock inside the water now, let's say, okay. This water level increased to, let's say, it was somewhere here, right? Okay. So this difference, so it was 500 and it became 650, right? Yeah, centimeter cube. So what is this increase amount? So it's 150, right? This is going to be volume of the rock, actually, guys, okay? Volume of the rock, okay? And what's the question is, we have to calculate the density of the rock. What is the density? Density is going to be mass over volume, right? So usually I teach my students how to remember the density formula. It's like we have a heart here, and it's going to be the arrow, let's say, okay. Heart broken, right? So let's erase few parts, and we may clearly see it's going to be, mass over volume. Yes, exactly. So it's going to be density. Oops, my bad. Okay, let's take the red color. Density is going to be mass over volume. Yeah, whenever you see density, heartbroken, so it's easy to find. Okay, anyway, mass is provided to us. It is going to be, what was it? Yeah, 360 gram, okay. And the volume we just calculated, so bring up the volume here. So it's going to be, 150 centimeter cube. Do we have to calculate it? No. So even just dip it in terms of fraction. It's easy. So it's A, right? Next problem. 29. So it's related to moment, I guess. Yeah. So diagram shows a beam of XY of length 1 meter, basically 100 centimeters. The weight of the beam can be ignored. Yeah. We assume there is no any weight of the beam. There is a pivot of 40 centimeters from end X, and load of weight 17 newtons is suspended at end X. Okay, so we have a pivot here. It's the place where it starts, the point actually, where it will rotate, right? So this is counterclockwise and this is the clockwise. Anyway, so end X is going to be 40 centimeters from pivot, and it has 17 newtons suspended here. The load, object, box, or whatever it is. The beam is balanced by a force acting at 10 centimeters from end Y. Okay, so there's a force here. Okay, someone is just hanging maybe, or a kind of force pushing maybe, or pulling, doesn't matter. So there's a force and it's 10 centimeters away from it. But this is not the lever arm, right? This is not the pivot distance, so we should be careful. What is the magnitude of the force? What is force basically, okay? So we have two moments here. One is clockwise, one is counterclockwise. So moment x counterclockwise, it tends to just, rotate the beam counterclockwise direction. And we have another moment from y, which is clockwise direction, is going to tend to rotate from clockwise direction. So they're in balance, they're in equilibrium, okay? That's what they're saying. So it means our moment y have to be equal to the moment x actually, okay? If you say moment x on the other, okay. So more consistency, moment x equals to moment y. So what's the, let's recall the formula for the moment. What was the moment formula? Force times distance, and force have to be perpendicular to distance, right? We have to remember this side as well. All right, so the force times distance for x equals to force times distance for y now. All right, let's take the blue, it's easy to see. Okay. Now, what is force x? Force x is given 70 newtons times distance. So distance has to be the point till the pivot point, right? So point where the force is acting to the point of rotation, pivot basically. So it's going to be 40 centimeters, or you may say 0.4 meters, okay? So let's use the SI units. Okay, now force times distance for what? Y. What is force for y? That's the question actually. We have to find it. Force for y times the distance. So we should be careful here. This distance is going to be 60 centimeters now. But are we going to take the 60 centimeter, or are we going to take the 10 centimeters now? We have to get the distance from pivot to the force actually, okay? So from pivot where it starts rotating to the force location. So it's going to be 50 centimeters now. 50 centimeter, or we simply say it, we will do it what? 0.5 meters, so it's just 0.5, okay? Okay, so let's write from the other side. So force y times 0.5 meters, okay? So now just rearrange, just 70 times 0.4 divided by 0.5. When you calculate it, just blah blah blah. So you will get it 56 newtons, okay? That's going to be our force. If you wish, what will be force of y, all right? So this is going to be B. Next question 30. The force acting on an object increases the kinetic energy from the object from 20 joules to 50 joules in 5 seconds. Okay? What is the average power produced by the force? What's the average power produced for the force during this increase in kinetic energy? Okay? So first of all, let's recall the power formula. Power formula is going to be work done per time. Rate of work simply, right? That's the definition of the power. All right. Now, what is energy? What's work done? Work done force times distance, blah, blah, blah. Simply, work is energy, guys. They're same things, okay? Work done and energy spent is going to be same. So, energy spent over time. How much energy we have spent it from 20 to 50? It's going to be simply 50 minus 20 equals to 30 joules, right? That's the changing energy, kinetic energy, whatever the energy is. Yeah, 30 joules. Over time is going to be 5 seconds. Okay, so the power is going to be 6 watt. What? Yes, it's watt. 6 watts, okay? So that much of power you need basically to increase the, probably object is moving here, okay? Or move the object, or simply spend 30 joules. Yeah, all right. 31. From which type of energy is electrical energy transferred in hydroelectric power stations? What is this hydroelectric power station? Basically, we use waterfall, right? Water to generate electricity. So we don't take electricity from water. We use water to generate electricity. So probably it's a waterfall, let's say, okay, it's going to be a rock here, the water is falling here, blah, 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 blah. It's not a hair, it's the water, okay? It is a water, okay? And we have a turbine here, basically, okay? And this turbine being connected to a generator, and this generator, well, it has the structure, blah, 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 and it generates the electricity, basically, okay? So which type of energy is transferred here? Is it chemical energy? Are we using petroleum or, I don't know, coal? No, we're not, okay? It's X, we're not using. Are we using electrical potential strain energy? Strain energy, basically, guys, where when we stretch the spring, let's say, or kind of squeeze it or stretch it, or let's say what we have, any object being stretched or, I don't know, pulled, pushed, okay, stretched, compressed maybe. So it's not the case, right? Is it gravitational potential energy? Exactly. The water has a mass, and it's what dropping down from certain height. So it's actually this one, okay? Not this. It's not nuclear energy. Nothing to do with nuclear reactions, or I don't know what is it. No, right? It's gravitational potential energy, exactly. Okay, question number 32. The liquid in a liquid in glass thermometer, okay, is replaced with a different liquid that expands more for the same increase in temperature. All right, so the scale of thermometer is changed because of a new liquid. Definitely, yes. What happens to the sensitivity and what happens to the range of the thermometer? So what we have changed, only the liquid, okay? Let's say this is the case of thermometer, and it has the what do you call this one? Bore, right? Or tube, let's say, glass tube. So let's say usually the thermometer, it's in red color, let's say, okay? We have thermometer here, let's say. We have reading, let's say this is 0 Celsius, 1, 2, 3, 4. Let's say this is 50, 1, 2, 3, 4, 5. Come on, 5, negative 50, let's say, okay? Let's say our thermometer, the old one, is going to show the range between 50 and negative 50. So 100 Celsius, right? Difference, let's say. Now we have changed the liquid only. What have remained same? The thermometer, glass, the tube, this glass tube is remained same. Oh. Let's say our new, that one is going to be yellow, let's say, object, I don't know, okay? Yellow, let's say, okay? Now, the thing is, they expand more comparing to the mercury, let's say, okay? So, what does it mean? So, for the small change, it's going to expand more. It's going to take more place. Volume increases, actually, okay? For the new, this is the old one, let's say, this is the old one, and this is the new one. For the new thermometer, our liquid, let's say, expands more. It requires more place. We don't have it, so it will affect the range directly. Maybe it will have only 0, 1, 2, 3, maybe 30, 1, 2, 3, maybe negative 30, or even less, maybe, okay? Because it requires more. So our range will decrease, definitely, right? So from 50, it decreased to 30. Can you see it? So our range will different. So sensitivity range, okay? Two factors we have to find. It will decrease, range decrease. It's not B, it's not D. So we have to find the sensitivity. How about sensitivity? How will this affect? Guys, sensitivity and range, they are inversely related, okay? Because the diameter, I mean, it's the same object, okay? It's the tube diameter, let's say, okay? It's going to be same. So we can compare them, that sensitivity is going to increase, actually. It will show more precise, okay? It's going to show more precise that reading, actually, because the range is less now, okay? So it's going to be this one, definitely. So the answer is C. Okay. Let's say the yellow one. Red one. Okay. So let me drink my tea. All right. One cause of air movement in atmosphere is convection, definitely. So convection, so we have three, right? Convection, and radiation. Okay, we have three ways of heat transfer. Conduction usually for solids, okay. Convection usually for liquids and fluids basically, okay. Fluid will include what? Fluid, okay. So air and liquid, okay. Liquids, okay. And radiation would be for vacuum, right? Anyway, so one cause of air movement in atmosphere is convection. Okay, which statement describes air that rises in the atmosphere due to convection? So raising what? Raising air is going to be hot, right? Hot air will raise. Cold air will sink, guys. Okay, it will go up. Hot air will go up elevation. Cold air will go down because cold is more dense, hot is more less dense actually, okay? So that's why we put the air cons on the top, not the bottom, right? Top of the room, let's say. But the heating radiators, let's say, or whatever we use bottom of the room, let's say, okay? To the floor, actually, yeah. So raising means for the warm the air actually, and it's less dense, not more, but it's less dense, okay? The answer is C. Okay, 34. The critical angle of diamond is 25. Okay, this is our critical angle, so 25 degrees. Light travels faster in air than in diamond, yes, because air is loose, diamond is dense zone, that's why. Which diagram shows the path of light passing from diamond to air? From diamond to air, okay? Let's see which one is correct. Guys, A and C is definitely wrong. Why? Because it's 30. Incident angle is 30. It's more than 25. It have to be totally internally reflected, okay? A and C is totally wrong. B and D. The difference is B bending towards normal line, shaded with normal line. And on D, it's away from normal line. Which one is correct? Guys, remember this one. Light travels, okay? So let me explain in two cases, okay? From dense to loose zone, okay? From dense to loose. Or let's say light will travel very slow in dense zone and it will travel very fast in loose zone actually, okay? It will bend away from normal line. Away from normal line, okay? From normal line. So it's going to be, it's going to bend away from normal line. How about opposite? From loose to dense, okay? Okay, it's going to be slow here and it's going to be fast. From loose to, sorry. In loose it will go very fast, okay? But in loose it will go slow, okay? So it will be towards the normal line. Towards the normal line, NL normal line, okay? So answer is D here, from diamond to air, from dense zone to loose zone, away from the normal line, yeah. Okay. Question 35. The speeds of sound in three different states of the same substance is 480, 1500, and 1800 meter per second. Well, certain substance, let's say. Which row will give you the state of each of these speeds? Now, speed of sound in air is around 400, okay? In air around 400. In water it's 1500. In solid is going to be even higher. So in this case it's going to be 1800. So sound is going to travel very fast in solid. Normal, let's say, in liquid. In air is very slow, okay? So this is gas, liquid, solid, definitely. So answer is A. All right, question number 36. Which type of magnet can be switched on and off many times per second? It means very fast, okay? Yeah, per second, let's say. And electromagnets only, sorry. And permanent magnets only, both electromagnetic and permanent magnets, neither electromagnetic nor or permanent magnets. Well, guys, electromagnets can be switched. We have seen the applications, right? It's in per second, like switch off the electricity, it's going to be not magnet. Switch on magnet, like instantly, okay? So it is this one. How about permanent magnet? Well, permanent magnets can be demagnetized. There are some methods, but it takes like hours maybe, or days maybe, okay? It's going to take very long time. It's not easy, okay? So it's only electromagnets, okay? C and D is wrong. Okay. Plastic rod is rubbed with a cloth causing a negative charge on the rod. Okay, which statement is correct? Very easy. Okay, we have a plastic rod and we have the piece of cloth here. When you rub them, guys, what it says, plastic rod and cause negative charge on rod. What does negative charge on rod means? So minus plus, let's say minus plus, and here plus minus plus minus plus. Okay, whatever. It's neutral. When you rub it, what will happen, guys? When electrons want to, let's say to, it was whatever. Okay, imagine it was. Sorry, so we have to put minus here. Sorry, minus here, right? So now it's equal. Yeah. So when you rub, when electrons from this guy transfers to other side, this rod is negatively charged now, okay? So this is going to be clothed, right? Yeah. Now, which statement is correct about this? Or which statements are correct? The rod gains electrons. Definitely it gains, that's why it's negatively charged. The cloth loses electrons. That's why, yeah, it loses, gives out the electrons to rod. It's not coming from somewhere else. It's coming between, the electrons are sharing between these two guys only. So, yeah. The cloth becomes positively charged. Definitely. So, when you have a look to cloth, it has more positive charge. No protons, more protons. So, it's going to be correct. So, the answer is D. All right. 3 more questions left. Okay, cool. The maximum current in a food mixer during the normal use is going to be 3.1 ampere. What is the most suitable rating for the fuse used to protect the mixer? Imagine you have a mixer and it has that 3.1 ampere, okay, and it just blew, okay, and that fuse is blue. Just yeah, you have to replace it now. So which, if you had these options, which one you would choose? Now you cannot choose one. It's very small than 3.1. It's going to blow very fast, okay, even before your what I mean is your mixer needs 3.1 ampere at least, okay. If it's less than that, fuse will blow and it will not allow any current to pass, so it won't work. 3, it's less, so it should be bigger than 3.1, so either 5 or 8. So which one? So you have to choose the very close one. If you had 3.5 ampere fuse, it would be awesome to use it. It would very perfectly protect your device, because when your device gains very high ampere, it's going to damage your device. So ampere, like imagine you put 8 ampere fuse in your mixer, so it will allow 7 or 8 even pass, okay, but your device needs only 3.1. Maybe slight little higher, it will rotate faster, it's okay, but very high, it's going to damage it definitely, okay. So it should be higher than the fuse required amount, but little, very close to that amount actually, okay. So it's going to be 5 among the choices, so it's C. All right, 39. Current carrying wire is placed between the poles of magnet as shown here. The current direction the wire is shown. The force is produced on the wire. Which label direction does the force act? Everyone. We have rules, right hand rule or left hand rule. We have studied this one, right? Let's say there are 2 rules for determining direction. So which one we will be using here? If you remember, guys, okay, here we have left hand rule and right hand rules. The factors are same, okay? Your thumb is going to be motion, first finger is going to be pointing finger, it's going to be the field, and your second finger is going to be direction of the current all the time. But which one are we going to use it? If you use right hand rule, it will give you different direction. If you use the left hand rule, it will give you different direction. So which one is the correct one then? Now, there are some keywords, guys, okay? Current carrying wire. wire carrying current, current running in the wire, in the circuit. So this is going to be motor effect, guys. Motor effect. We simply call it motor effect. So you will use left hand rule, okay? In motor effect, you will use left hand rule. Why? Because we have only one device. Generator generates electricity. Motor uses electricity, right? So simply we have generator. Let's say device here. So here electricity runs, and we have a turbine here, okay? Now, if you remember that earlier we had a problem related to hydroelectric power, right? When water rotates the turbine, it generates electricity. That's called generator effect. Okay? So in here we will use right hand rule. Right hand rule, okay? We will use right hand rule. So what kind of keywords they may mention for generator effect? It would be induced electricity, generated electricity, induced current running in the wire, okay? So this might be, if you see induced or generated, definitely is going to be generator effect, okay? So you will use your right hand rule. But here it's saying current carrying wire. So it's motor effect, it's using electricity, it's already been produced, okay? So we'll be using our left hand rule here, guys. All right. So how are we gonna do? So please do your fingers, just have a left hand rule side, okay, left side only. So make the same side, okay. So motion up your finger towards your PC, if you look into your PC or paper or book, and the finger is going to be second finger is going to be to your right. Okay, so just do this way. It's going to be same. Now please point your pointing finger, first finger, inside the page. And, okay, so, by the way, guys, let me just mention it here. This right hand rule and left hand rule, the factors are very same. Your thumb is going to be motion, first finger is going to be field, second finger is going to be current, guys, okay? Yeah. So, current is running inside the page, guys. Sorry, earlier I said pointing finger. It should be second finger, right? So your second finger, imagine, is going into the page. If you look into the screen, just make it into the screen, okay? Going inside the screen. Now, do we know that what is the magnetic field here? Guys, it's given but not directly. They haven't mentioned it, but in the picture they have given us. From north to south. So magnetic field will always run or go, or point from north to south all the time, okay? So please make your second finger inside the monitor, into the page. Your first finger will point directly, guys, from north to south, from your right to your left, okay? Then you will see your thumb is showing upward. Oh, it's showing upward, okay? So it's B, definitely, okay? Well, yeah. So if you're a little confused here, you may see the videos, animated videos. So they will show you more realistic, let's say, what is that? You will see the picturized actions, okay? In YouTube you can find it a lot, okay? You find it a lot, so you can practice more. Yes, but here, guys, remember this one, okay? The first point is going to be determining, is it left hand rule or right hand rule? So current carrying wire carrying current, or current running in the wire, in the circuit, this would be a left hand rule, motor effect all the time. But the induced electricity, induced current, it will be definitely, or generated current will be right hand rule. Okay. 40, question number 40. The diagram represents pair of nuclei of some atoms, okay? Which pair shows nuclei of different isotopes of the same element? Okay, same element isotopes. What are they? Let's remember. What is isotope? Isotope is going to be same proton number, right? Same proton. Different neutron. Okay? So this is going to be isotope, guys. Always remember. Okay, so which one is it? So we are looking for the, okay, So dashed ones are going to be proton, empty ones are neutrons. So we are looking for the same proton first. So A is different proton, definitely. B is same proton. C is going to be different proton. D is going to be same proton. Now, neutrons have to be different. Okay, B has 1, 2, 3 on the left side, 1, 2, 3, 4 on the right side. Yes, it's correct. D, 1, 2, 3, 4, 1, 2, come on. It's same, this seems same element, right? Sorry. Same atoms, okay? Same atoms, okay? So it's not, okay? So the answer is B here. Very easy, okay? Straightforward. Yeah, end of question, guys, okay? But here, they all the time provide us this one. Probably you need this one for chemistry. We don't need it. Okay, yes. So I hope you'll find this one helpful, and good luck for your exams.